All right, welcome everybody. Today we have a special group of folks that are returning to us from Trino Summit just a couple months back. And they are going to be talking about building a federated, cost-effective, highly efficient query platform using Trino. And this is, of course, the EA, that is that correct if you were wondering, the Electronic Arts Gaming team. And this team particularly runs the analytics, the stuff that we don't really think about when we think about a gaming company in the background, basically taking in the user data, all sorts of ways that users are using the different gaming systems, networking across, and trying to find different errors and issues. We're really excited to hear a lot about what they've done. We heard a little bit about it in Trino Summit, but we're going to hear a slightly different spin on what was presented there. So if you are coming in from Trino Summit and you've already watched the EA presentation, there will be a little bit more varied information coming into you here. So let me make sure, for some reason I'm not, there we go. So the agenda today is going to be, first, as usual, I do the community stuff. I'm going to be talking about a little bit of the things that you can do, like swag and some resources out there. I also wanted to take a quick little endeavor into mentioning, for all those that are not aware, there's been this thing that has come to all of our attention in really the last week, called the Log4Shell vulnerability. And I wanted to really fast, let me just go off the script real quickly and see if I can bring up Twitter without too slow of internet connection. And I wrote a blog that covers the specifics that you may want to know about this Log4Shell, not Log4Shell in general, but basically the specific ways that Log4Shell or Log4j2 dependencies have been found in Trino. Now, I want to be very clear, Log4Shell does not affect Trino, because the one affected dependency that we did have was not actually used in any of the code paths. So that's just the short little summary. In short, if you're using Trino, you don't have to worry about Log4Shell unless you've done something like created a custom plugin that has a Log4j2 dependency. So I wanted to bring that up, since that's been something that's been discussed a lot recently, especially in our community forums. So back to our regularly scheduled program. If you do have any more questions about Log4Shell or developing on Trino or using Trino, anything really Trino related at all, or you just want to talk to me and say hey, or anybody else there, you should join us on the Trino Slack channel. So that's at trino.io/slack.html. It's also, if you just go to trino.io, easy link to click on the first page there. So that is our kind of general resource that I point people to find other people in the community, to ask questions and learn more about Trino. So that's a really good place to get started, especially for all you Trinoobies out there. And then we also have this now monthly. I always want to say bi-weekly, but we just switched to monthly so that I can clear up my schedule to do other cooler things that I'll be announcing shortly. But we have a Trino community broadcast that comes your way every month now. And we basically, myself and my co-host Manfred Moser, we dive into just various aspects of either the ecosystem or different resources around the Trino ecosystem, the Trino connectors, and all things kind of related to your typical workflow around Trino. So it could be ingestion, it could be reading data out, it could be ETL processes, or different tools around Trino. So we talk about a lot of stuff there, and it's definitely a fun broadcast, we bring on different developers that contribute to Trino and get their experiences in the community as well as what they've contributed recently. So definitely check out trino.io/broadcast. Where we have one coming up this week on Kubernetes, deploying Trino to oh my God, I always want to say the EKS. No, EKS is the one that's Amazon. I always want to say AKS because I think Amazon Kubernetes service, but it's actually Azure. So that's the one that's in Microsoft stuff. Anyways, so check out Trino Community Broadcast, trino.io/broadcast. We also have these meetups. You are currently at the Trino Americas meetup, but we will be ramping one up in EMEA. Occasionally, we have a community-led one that happens in the Asia Pacific region, and we will be slowly having more and more of these happening in the European time zone as well. And then, of course, if you are not in any of these time zones, these will all be recorded, and you can watch them on your own time in your during morning time wherever you live. Okay, or it could be nighttime wherever you live if you really prefer to be a night owl. I know a lot of developers do that. So finally, if you want to contribute to Trino, very good way to get started is to go to trino.io/development. It goes over a lot of the specifics like signing up for a CLA, how to get started, some initial things you want to consider in contributing, and then essentially reach out to us on Slack. Then other ways you can contribute that's not just through code or writing tests or things like that. You can contribute to us through our blog. We do have a blog, the one that I was particularly linking before on Twitter. You could just write about your experiences using Trino, developing on Trino, particular interests that you have to anything really interesting that you have to talk about that other engineers could benefit from. We want to put it on our blog. So reach out to me on Slack if you're interested there, and it'll get hosted at trino.io/blog. And then we also have docs. If you are someone who wants to improve the documentation, definitely go there. And all of these links are being shared here at this starburst.io info Trino community resources link that we just posted in YouTube. So with not much further ado, let's go to the next thing. Another resource that my colleagues and myself, particularly myself right now, because I'm a developer advocate team of one, but I have put together this Trino forum. Basically, it is an extension of the Slack channel. So there's a lot of discourse. There's a lot of chaos going on in Slack. People just, talking back and forth and, getting really good results. But what's really hard to do is it's hard to find that information in Slack once all of these conversations have transpired, right? Especially if you're a new person trying to find this information. None of this stuff gets indexed by search engines anywhere. So I built out Trino Forum, and it's a new thing that is now being graciously hosted by Starburst. And it's basically a place where we can take a lot of that internal knowledge that's kind of stored in Slack, and then we put it on Trino Forum, and then it's now searchable through something like Google, and will allow you to be able to find a lot of these common issues. So this was my solution. Rather than making a frequently asked questions page, let's just make a forum page, and it's been working well pretty far. Do join there and contribute if you have questions or answers to help other people out in the community. And finally, we have these shirts that we give out at these meetups. If you have not gotten a shirt before at one of these meetups, please do go to, and this link is also on the link that we just sent out to YouTube, which is starburst.io/info/Trino t-shirt meetup November. Looks like we did not. I don't know, Anna, should that be December? Is that, or do we keep the same link?
It's the same link. It's good.
It's the same link. Okay, so keep using this link. Don't worry that it says November. and essentially go there. There'll be a form to fill out about your t-shirt information and things like that. And then we will send you a t-shirt provided you are in a country that we are able to ship it to. Otherwise, we will give you a nice little gift card and hope that we can eventually ship to your country shortly after. All right. Any questions that you have for us, please do ask on the YouTube chat, and basically join Trino Slack if you do have any questions after the show. With all of that, I do want to hand this over to my partner in crime, Neetu Goswami. And Neetu, can you tell us about this amazing query engine we have called Trino?
Awesome. Thank you so much, Brian. For those of you who are joining us for the first time, welcome. Love to be part of this open source community. And today I'm just going to be walking you through what is Trino, what is Starburst. But first off, my name is Nitya Goswami. I cover all of Eastern Canada at Starburst. I've been with the company for about 4.5 years now. And before this, I spent 2 years at Databricks, helping organizations through their data and analytics journey. So welcome again. So first off, I want to cover what is Trino, okay? So Trino, which is formerly known as Presto SQL, it's an open source distributed SQL query engine created by, as you can see, Martin, Dane, and David. In 2012, when Dane, David, and Martin joined the Facebook data infrastructure team, together with Eric Huang, they created Presto to address the problems of low latency interactive analytics over Facebook's massive Hadoop data warehouse. Okay, so Trino is a distributed SQL query engine that allows you to perform fast SQL queries on large data sets. That's the key thing over here. And Trino was created to empower analytics anywhere. And with proven scalability and high concurrency, users can combine data sources, many data sources, but I'm just going to name a few: BigQuery, Elasticsearch, MongoDB, PostgreSQL, separating compute and storage functionalities. And the ability to quickly and easily extract insights from large amounts of data is increasingly important to technology-enabled organizations, right? Every organization is trying to leverage data and trying to see, like, how can we get more out of data? So as it becomes cheaper to collect and store vast amounts of data, it is important, and it's becoming super important, that tools to query this data becomes faster, easier to use, and more flexible, right? So using a popular query language like SQL was imperative, and that's why this was created. But this can make data analytics accessible to more people within an organization. So Trino was designed to be, or is designed to be, adaptive, flexible, and extensible. It supports a wide variety of use cases with diverse characteristics. These range from user-facing reporting applications with sub-second latency requirements to multi-hour ETL jobs that aggregate or join terabytes, exabytes, petabytes of data. It provides an ANSI SQL interface to query data stored in Hadoop environments, open source and proprietary RDBMSs, NoSQL systems, and stream processing systems such as Kafka or Kinesis. Trino also allows organizations like AWS, Netflix, LinkedIn to deploy a single SQL system to deal with multiple common analytics use cases and easily query multiple storage systems while also scaling up to 1,000 nodes, its architecture and design have found a niche within the crowded SQL on big data space. Adoption in the big data space is growing quickly thanks to the open source community like ours. But as great as Presto is, there was definitely a big opportunity to build upon open source Presto to create an enterprise-grade Presto. So our founding team has been involved in Presto since the beginning. In fact, the creation of Starburst started at Teradata, where our founders were already working on Presto, contributing significant time and engineering hours as the number 2 committers behind the Presto creators. So the Presto creators are, in fact, now part of the founding team, and they are the executives at Starburst. Starburst was created on top of Trino to give you enterprise-grade performance, connectivity, security, management, and support your company's growing needs. So with Starburst, the enterprise-grade edition of Trino, you can have a single point of access to all of your data. Doesn't matter where it lives, on-prem, in the cloud, hybrid, multi-cloud, it doesn't matter. No matter where it lives, without needing to copy and move the data. So we're substantially reducing data movement as well as ETL pipelines. Starburst is also the analytics engine for data mesh, a decentralized, distributed approach to enterprise data management. Starburst can also be deployed anywhere and managed with insights. It's a really cool UI. You can see, who's querying what, how many queries are being, put on that particular source. So data teams can holistically view their cluster operations and query execution so they can reach meaningful business decisions faster. All this with the support of the largest team of Trino experts in the world, delivering the fully tested, stable releases and available to support you 24/7. To unlock the value in all of your data, you need a solution that easily fits with what you have today and can adapt to your architecture tomorrow, which is what we call optionality. Okay, so Starburst gives you the fastest path from big data to better decisions. Where we sit, like how we like to think of ourselves and how our customers describe is sometimes a consumption layer, semantic layer, abstraction layer, or the analytics engine for data mesh that sits right in between any end user accessing data through tools like data science tools like Jupyter Notebooks, or data analysts like BI tools, Tableau, Power BI, SQL, etc., and the underlying data sources or sources that we do, cross any deployment or hybrid deployments. So any of those, sources, whether they are on-prem, in the cloud, or multi-cloud, can be easily accessible through the tools that your data teams are already using. So with that, I'm excited to welcome the EA team, who will be talking us through how they are actually using Trino, building a federated, cost-effective, highly efficient query platform. Welcome, EA team.
Thank you, Neetu. Thank you, Brian, for the introduction. Are you able to view my screen fine? Okay, I think that is a go ahead. Good afternoon, everyone. We're here to talk about how we build a federated, cost-effective, and a highly efficient query platform using Trino as a core engine. Just to give you, in case you don't know, EA or Electronic Arts is responsible for some of your favorite games, be it FIFA, Madden, or Sims. EA exists with one motto: to inspire the world to play. And EA has a number of game studios within their umbrella: Frostbite, BioWare, PubCap, Respawn even. And let me give you a brief introduction of who we are. We are part of an org called EA Digital Platform. EA Digital Platform consists of teams like Gameplay Services, IT, Data and AI, CNI, and so forth. The role of data and AI is to provide a player network framework. It is, in fact, a data framework that we build in working with game studios, analysts, data scientists residing in different game studios or central orgs that ingest data from different games into a central platform or a central repository. We work as one central data platform team, and we manage querying the data, running batch processing on this data, allowing created or processed data. We handle the ACLs around who can access what kind of data. Another important role that we play is to support different game studios and their data engineers and data scientists access these data in a highly performant and efficient manner. So, having said that, the scale, as you can imagine, the scale at which EA works, the more number of game studios, the more player base means more data. The data set is in petabytes. We see tens of terabyte data generated each day. We have thousands of ETL jobs running on this data. And as I mentioned earlier, We have 20 plus game studios all across the world, and again, engineers, analysts, scientists within each of these game studios trying to access this data. To summarize the overall scenario, or the overall situation here at EA, we have game studios that have embedded analyst teams, or which include data scientists, machine learning engineers. We also have varied data pipelines that run accessing data from multiple sources. So data does not necessarily have to reside in, say, a MySQL database. It could reside on the cloud, on AWS's S3. It could reside on Google Sheets. It could reside in multiple such locations, but and sources. But we needed a way to run data pipelines or ETL jobs on all of this data. So we also had the need to support hundreds of thousands of queries on our platform on any given day. Of course, when we are building out a platform such as this, there is a need to have very high service availability. We cannot afford to have outages that last for 15 plus minutes. That it would cause significant delays in our overall pipelines and overall metrics, dashboards. We would see a large impact. And as different game studios use our platform for varied requirements, it could be dashboard reporting, running machine learning models. Each of these have a varied SLA requirements. So in case of generating reports or dashboards, we probably want fast query execution. In the case of running ETL pipelines doing batch processing of data, fairly average or fairly moderate SLA requirements. In some cases, we would want to run some ad hoc queries to generate certain metrics against average SLA requirements. So we needed a data platform that could provide all of these functionalities and services. Having said that, I just wanted to give you a brief overview of what our query platform looked like before Trino. So we used Hive as the core engine for our ad hoc query platform. With Hive, there was a necessity to store the data on HDFS or on the cloud, but we had to leverage the yarn queues to manage swim lanes across different teams. It had limited scaling capabilities. By that I mean during the game launch season or holiday season, when we would see an increased traffic, there was a need to statically scale up the node managers or resources needed on these Hadoop clusters. And as I mentioned earlier, it's since all the data is stored on HDFS, there was one single large Hadoop cluster running that was pretty much supporting all these game studios and all these analysts and scientists. With such a static framework, there is an increased operational overhead. And having said that, today we use Trino as our core engine, and we are able to access data that might reside in the cloud, that may reside on MySQL, that may reside on Google Sheets, tomorrow even BigQuery. So it is a fairly flexible scenario that we've been able to achieve. With the new query platform, with Trino as a core engine, we were able to achieve intelligent routing of queries. We'll definitely talk more about that today. And we were able to achieve self-serve scaling capabilities. By that I mean, if FIFA decides to launch in September or October, they can spin up their own cluster. They can scale up their workers and build out their own Trino cluster, route their queries to that cluster to meet this increased traffic or increased demand. Having said that, there's also the ability of having individual clusters and shared clusters. By that, there may be scenarios where the workload isn't as high, and we can have two or more teams share a single pool. This is again achieved with the new query platform. And all in all, we are able to achieve zero downtime today, which is a big win. And again, we will go ahead and talk about the overall design, the overall architecture that would show you how we are able to achieve zero downtime. What we think about when we think about the future with Trino and our query platform, we definitely want to achieve improved workload management. By that, we want to have the ability to auto scale, auto shutdown, auto manage resources across all these clusters in a more intelligent manner. And of course, we are currently working on a self-serve config management. By that, giving game studios, giving game teams the ability to integrate these Trino clusters with multiple data sources. If they want to integrate with, say, a MySQL database, they want to integrate with S3, they have the ability to go ahead and manage these configurations by themselves. Having said that, to just summarize, the query platform that we wanted to build had 4 main objectives. It needed to be multi-tenant and support varied SLAs. It needed to allow for flexible allocation of resources. And also, it was very important to have an ease of interfacing. By that, I mean easily be able to configure this platform with multiple data sources, or be able to interface with this engine using a UI, using API, using very tools like Looker, Tableau, various BI tools in the market. And also, of course, with any given query platform, we had a stringent requirement of having a 99.7% service availability, which means zero downtime. And these were the 4 main objectives that we wanted to achieve when we decided to go ahead and build out our query platform. Having said that, let me jump into the overall design in order to achieve these 4 main objectives. So initially, when we did start off with designing our platform, we had a platform UI, we had platform API, users also did use third-party JDBC clients to access these Trino clusters. In the case of API, it was okay to put a standalone Trino cluster behind the API and have queries routed to that cluster. Before you know it, every team for wanted guaranteed resources, or wanted their queries to meet certain SLAs. So we decided to give each team a dedicated cluster. And as you can imagine, FIFA would have a dedicated cluster, Madden would have a dedicated cluster, Sims would have a dedicated cluster. Depending on use cases, we were able to statically route queries even via the API to another cluster. As you can see, this overall design had several flaws. One being, it was extremely complex. There were multiple workflows. There was API, there was UI, there are several JDBC clients, there were several standalone instances. And there was a lot of redundancy in code. There was lack of standard features. And with all of that comes increased operational overhead. And of course, there were scenarios where you would find one cluster which was overutilized with 100 plus queue queries, and you would see one cluster lying idle for 5+ hours. Of course, with the Trino coordinator, you may see an overloaded coordinator crash during peak processing hours. And again, as I mentioned earlier, it was an unbalanced workload. There may be situations where teams utilize one cluster heavily, but another team in off hours are not leveraging another cluster as much. So this led to unbalanced workload all across the platform. So let me go ahead and tell you how we were able to address these issues. So we decided to use Lyft's Presto Gateway, today known as Trino Gateway. They had open sourced it early 2019, and we decided to incorporate the Trino Gateway as a single point of entry for all the queries that enter our platform. So be it if the query was submitted via the UI, via the API, via any third-party client, it would still go to the Trino Gateway and be routed to various clusters from there. We also introduced a workload management service. This workload management service allowed users to be able to scale up and scale down their clusters, or provision new clusters as and when needed. But when as you know, when you try to integrate any open source code or open source tool with an existing platform, there are certain outstanding issues that needed to be addressed. So the first issue was that the Presto gateway back then was a single instance. So even though it was serving as a single point of entry, it also became the single point of failure. The second issue was query routing was still static. By that I mean, based on certain username, queries would be routed to certain clusters. There was no intelligent way of determining where queries ideally should ideally run in order to manage workload. Third, the third issue that we noticed was basically load balancing between the clusters was still in a round robin fashion. Round robin, although effective in some scenarios, is not the best way to load balance across multiple clusters. So I should mention that we decided to work with the Lyft Presto Gateway team in order to make the Presto Gateway highly available. We contributed that back to the open source project, and today it is highly available. We are still working on contributing back a routing rule engine, which allows for dynamic routing of queries. There was a team that contributed intelligent load balancing back to the community. So working alongside them, we were able to address these three primary issues with the vanilla version of Presto Gateway, Trino Gateway. So how did the improved design help us, or how did the improved design work well for us? As I mentioned earlier, the Trino gateway would sit in front of all these multiple Presto clusters, but then we were able to introduce something called as a logical grouping of these clusters called as routing groups. So we would have one routing group, say for BI use cases or dashboard use cases. We would have another routing group, say for a game studio or analysts and scientists in a particular game studio. We would have one particular routing group for just ad hoc use cases, new engineers, ETL engineers, folks analyzing or generating certain metrics to run their queries on the ad hoc routing group. Now, by just looking at this particular slide, I think the advantage becomes obvious. Whenever there is a routing group that contains two or more clusters, we can load balance between these clusters. Two, we can achieve high availability. In case one cluster goes down, we can retry those queries on another cluster. Three, we can perform maintenance on these clusters without downtime. We can gracefully take out one cluster from a routing group, rely on another cluster, and be able to still achieve our service availability requirements. And this also allows for an easy and configurable workload management service. By that I mean, teams now can specify that they want to add another cluster to their routing group in order to meet additional workload requirements, or in some cases they want to remove a cluster or shut down certain workers when they have completed processing, say last 2 years worth of data. So routing group helped achieve these advantages. So with this improved design, one, we were able to simplify the workflow. So by just introducing the gateway, we were able to achieve a single point of entry into our overall platform. We were able to achieve dynamic access to multiple clusters. So we no longer needed to provide a single CNAME to a particular coordinator or TNS name to a particular coordinator to a client and just ask them to rely on that one coordinator. We were able to determine in real time where a particular query should run. We were able to reduce operational overhead. Of course, we were able to achieve we were able to optimize for resource consumption. So we are currently working on shutting down clusters when not in use, or scaling down resources when not in use. Of course, then the fifth and main advantage was definitely zero downtime, and lastly, load balancing capabilities within clusters in a single routing group. Yen would be speaking more about how we actually achieve these advantages. Yen, handing off to you now.
Okay, thank you, Preeti. So achieving zero downtime, Preeti, do you mind muting yourself?
Yes.
Yep. Next slide. Yeah, so right here we have these Treno gateway routing query to cluster A, and as Preeti mentioned, we have this concept of routing group that this routing group may have another backup cluster, cluster B. Preeti, can you click on the next slide? Yeah, so basically, cluster B will work as a backup cluster whenever A is needs to be upgrade or needs to be restart or needs to be do whatever maintenance we need. So in such case, we'll deactivate cluster A from the gateway. So now all the query will goes to cluster B, and we can do whatever maintenance needed for the cluster A. Usually for us, we'll do like a daily restart. We'll do like a configuration upgrade or do any hotfix needed, and we will at the same time send shutdown signal to the workers. So basically relaunch all the workers in cluster A, and finally when the maintenance is done, we will add it back to the Treno gateway so that we can, get back to where we originally at and do the maintenance for cluster B. So that's how we achieve zero downtime maintenance and essentially provide a better SLA to our game team. So and next one, I want to talk about physical design. Next slide. So here's the diagram, and first let's talk about the left side. So as you can see, everything on the left side is hosted in EKS, which is Amazon's Kubernetes service. So we choose Kubernetes as our orchestration system because it provides easier deployment and config management tool for us. And as you can see here, we have platforms, Query Platforms UI pod here, Query Platforms API pod, and the gateway pods right here all have more than one pod running, so we can have high availability. For the Trino master pods, we also launch it in the Kubernetes world because it's a relatively low loading part, and we sometimes needs to update their configuration. So, and we also need Kubernetes to help us to basically monitor this master pod closely. So say something is wrong with the pod, it can very quickly launch another one to catch up the workload. And on the right side, we have Trino workers because the actual computation workload is running in workers. So we use the standalone EC2 instance from AWS to fully utilize all the CPU, all the memory, all the resource we purchased. And by using a separate auto-scaling group for each cluster, we are able to scale each Trino cluster separately, and we have this clean separation between teams. As you can imagine, FIFA's team's workload won't impact Madden team's workflow or Sims team's workflow. So that's how we achieve this swim lane. And finally, as you can see here, we have a larger part on in the first row and larger instance in the first row and smaller instance in the third row. So AWS basically provide various of instance type for us to use. So for us, we can choose whether or not we want to have a bigger node or we may want to have multiple smaller nodes to serve the workload. So that is totally based on the query type that runs in the Trino clusters. So that's some optimization and tuning that we can do for the each Treno cluster. So next slide. Right. So another thing we have worked on and contribute back to the community is the routing rule engine. So routing rule, the vanilla Presto gateway or Treno gateway can only do round robin query routing, but we built this rule engine to route query based on four different aspects. First, we have the based on query type. So the reason we have this is because sometimes we find that a certain version works better with certain types of query. For example, we find that the delete query works better with Trino 319, and so we may upgrade all the other clusters, but keep one or two 319 cluster as the delete cluster. So same for the show create table query that has some bug in later version. So we are able to route these types of query to a previous version of Treno. So we can keep up with the newer version of the Treno release. The second one we use is we can route based on the session property. So user can set session property. So something like this, we call it a hint, like basically telling ruling engine that we want that a user want to route this particular query to FIFA cluster. So this is particularly useful for ad hoc user or for UI user, so they can submit their query to a different cluster easily. And third one is based on the user detail. So because in most of the case, we already know that a certain user belongs to a certain team. So we can, instead of routing this user query to a public or the ad hoc cluster we have, we can route these particular users to his or her team's dedicated cluster. So he or she can benefit from this dedicated cluster of dedicated resource. And finally, we can route based on the source. So in our case, a lot of Presto query or Trino is actually reporting query. A lot of small reading query sent out by Tableau, by Looker, or Superset. So these kind of query will go to some special cluster that has higher concurrency. And for those query from ETL workload, may be routed to some other cluster. So next slide. So here's how our routing rule engine works. So on the left side, we have different kind of user. So within EA, game team or self-serve service team, they will have some self-serve user or self-serve admin, and they will have some self-serve service account that is only for their team. And for public, these mean that public journal, they may belongs to the centralized team, something like that. And in such case, we can have a rule engine to decide which cluster should the query goes to. So in here, you can see the gray line is routing based on the username. So by default, username, human user, the first two human public and self-serve user will go to the ad hoc cluster. But if we detect that this query is coming from a self-serve service account, we'll send the query to the self-serve cluster. So that's the gray line. The second one is the orange line, the P2, Tableau. So it has a slightly higher priority, meaning that all three client query will be forward to the Tableau cluster, which has, as I mentioned, have maybe higher concurrency or faster read configuration. So this is a long-running Tableau cluster that is built dedicated for Tableau use case. So these kind of query will follow the orange line goes to the second cluster. And finally, we have the blue line using the hint I just mentioned in the previous slide. People can force, if they have the permission to do so, force query engine to send the query to the dedicated cluster. That is the blue line I have right here. So next slide. I think Yuanmeng will be talking about flexible allocation of compute.
Okay, thank you, Yan. So let me introduce something about the flexible allocation of compute. With this feature, so the customer can get their own dedicated cluster, so that they can run their query on their own cluster, and then the queries from different customer were not contained for the resource. So here is the design of how we launch a new Trino cluster according to the customer's requirement. So we have a GitLab repo of Terraform, which manage the EKS resource in our team. So if the customer want to have their own dedicated cluster, they can create a ticket, and then the DevOps team will submit a request, merge request in the GitLab repo, and then trigger the Terraform to create a new Trino master in the EKS cluster. Also, along with the creation of the Trino master, a new auto-scaling group is also created and also associated with this master. So the new ASG, there's no worker at first, and then we will add a worker later in it. So as Yan mentioned, in our design, the Trino worker is all Trino worker hosted in the AWS EC2 instance. And also with the creation of the Trino master and the ASG, the Trino gateway will connect to the Trino master automatically. Next slide, please. So when the user want to scale their cluster, they need to send some request to the workload manager API. So from the self-serve team, only the admin from self-serve team can allow to use this API. So he send a request to the API and specify how many resources, how many workloads the cluster needs, and then the number will be recorded in the workload manager DB. And we have an Airflow job which periodically retrieve the data from the DB, and if there's something changed, then the Airflow job will add the specified number of workers in the auto scanners group. Next slide, please. So to provision the worker resource for the Trino cluster, we have ad hoc compute pool, which maintains a number of workers. So if the user want to scale down their cluster, they will then the worker from their cluster will be thrown into the pool. And if the user want to scale up the cluster, also the Trino cluster will request the workers from the pool and add. And if they want more workers, they will move the certain number of workers from the pool into their clusters. So the reason we have this compute pool, because we have only fixed budget for every cluster. If they want to add more workers or reduce the workers, they have to retrieve the worker from the pool. And next slide, please. Next slide, please. Yeah, so here is about let me talk about something about the self-serve configuration management. Next slide, please. So we have a central repo, central GitLab repo, which manages of the configuration of all clusters. So sometimes if the customer want to modify the configuration, they can just create a ticket, and after our review and approval, then the developer was make a merge request into the GitLab repo, and then this change will be the configuration change will take effect after the restart of the cluster. So if the customer wants the configuration take effect immediately, they can restart the cluster when they make the change. But if we also have some scheduled restart for every cluster. So the user also can choose to wait for the scheduled restart time to have their configuration take effect. And the user also can manage their LCL by specify the ACL related information. Also, they submit a request. So, and then we will modify the ACL in the ranger based on their request. Next slide, please. Yeah, that's all from all of our presentation. So, any question?
All right. Oh, wow. What a really cool presentation, y'all. That was, I thought, just the exact same in with the Trino setup. This was like so cool to see how much you all have contributed back. And, particularly the Gateway project it's super popular. And I was not aware that you all were the ones that had added a lot of those resource groups and other pieces in there. So huge thank you from my end as well to say it's incredible what you all have done and added that. So wanted to mention that. I have a lot of questions myself, and we're waiting. I want to tell everybody right now, like, feel free to throw in your questions if you're on YouTube or LinkedIn. We're monitoring those. But while we're waiting for those to come in, I have a couple questions that I'd like to ask. So, how the first question that came up while I was watching was like, before you all had introduced the gateway and all these other pieces, how frequently were you kind of experiencing high availability issues or crashing Trino clusters? Was it pretty frequent whenever you would hit those high loads that you would see crashing happen? And how big was the demand going on during that time, if it was?
I can take that again. Feel free to add to it. So initially, since we were migrating the workload from Hive, we didn't know what the limit was. We did see improved performance in terms of just running benchmark queries, but we also didn't have in-depth knowledge of query optimization at that stage. So when we would run just Hive workloads as it is on Treno, we were hitting coordinator crashes quite frequently. And the one more thing that we noticed was when we have I/O operations, reads and writes, loading to table, we see increased GC issue. That is something we noticed quite earlier on. So with an increased GC issue, you would see coordinator crashes becoming quite frequent. We would probably see them on a daily basis. So there was a need to have a way in which we would be able to provide a service. Firstly, move the coordinator to EKS. That definitely helped us by it would automatically spin up in a couple of seconds, and that really helped with our high availability requirement. And then the gateway was an added bonus.
Yeah, so we've seen a lot in the field, when Trinos use the conventional way, probably up to about before Kubernetes had really taken off, right? The conventional way was just try to scale up your cluster actually quite vertically and instead of horizontally. And basically that's, make sure that you have more resources than what you're going to be throwing at it. But now with, Kubernetes taking off, containerization is, becoming a lot more available. And the way that Trino is architected with this kind of separation of storage and pretty much everything's running in memory at this point, it's a very easy application. Well, I can't say very easy, but you all make it look easy, and in terms of scaling it. So that's very interesting that you all have taken that route. Did Yen or Yuanman Meng, did you want to add something to that before I hop on to my next question?
Yeah, nothing for me. Yeah.
Okay, we did get a question from YouTube. This was asking, is the Presto Gateway the one from Lyft?
Yes.
Yes.
We worked with them in order to make it highly available. We do want to contribute the other features back, so we're hoping to do that sometime this year.
And that brings me to another question that I had from you. I haven't actually dug into the code yet of Presto Gateway, but how hard would it be to rename it to Trino Gateway, just officially?
So it would be fairly easy. I think we can create a ticket for that, and if somebody would be able to do it in a couple of hours.
Okay, we have another question, and so I'll leave this to one of you all because I have a lot of thoughts on this, but I want to hear your thoughts. How difficult is it to migrate from? We'll start out with PrestoDB to PrestoSQL because, PrestoDB to Trino because I want to be clear. PrestoSQL and Trino are practically two of the same thing. So let's say if you are on PrestoDB, how hard is it to migrate to Trino? Have any of you had an experience like this?
Quite early on, we stopped at PrestoDB version 270 or 273, if I'm not mistaken. That was when we decided to make the switch. We saw the community move towards PrestoSQL, and we made that decision to move to PrestoSQL. But in terms of ease of use, because we did it quite early on in our design, I guess the amount of effort involved was fairly less. But say we had to do it now, again, I wouldn't say it is impossible. I would say again it's fairly easy. It would take a couple of sprints. Yes.
Yeah, especially with a lot of the infrastructure that you have all built around it, I would say it sounds a little slightly more difficult. But I would also say that, provided you aren't writing a lot of custom plugins, that makes it a lot easier. So I've heard of some engineering shops, they write a lot of custom plugins around PrestoDB, and all of your code is really dependent on core code that is largely diverged from the other code base, the Trino code base. And then what version, may I ask what version you all are on for Trino or Presto? Are you on a PrestoSQL or are you on a Trino version right now?
Currently PrestoSQL 352, we are on the cutoff. So we're hoping to move to Trino 360 by next quarter.
Oh, great! Yeah. So there's another kind of jump that a lot of people have to make, and this is the less involved jump. The only thing I seem to see people have issues here. Obviously, you are changing a lot of namespaces, but if you don't have custom code, that makes it a lot better. So if you aren't dealing with plugins, it's much easier. But I'd say the biggest thing I've seen from LinkedIn and a couple other companies that have made this jump already, they said the hardest thing was that while we had already broken backwards compatibility because we had to change the namespace, we added in a second layer, which was grouping the connectors into a plugins or connectors folder or something like that. And so there was a one extra layer of folders that got added, and basically that changed the namespaces. But outside of that type of change, I haven't heard there being too many difficulties making the PrestoSQL to Trino namespace jump. So great question and great answer there. Let me make sure that it looks like we're good on questions here. Also, let me see how we are on time. Looks like we're running a little bit on time, but I have a couple other questions. Where's the information for the routing groups stored? Is this actually in the the runtime service, or is there a database that Presto Gateway connects to? I've actually never personally used it.
We have, when we made the Presto Gateway highly available, we added a persistent layer MySQL DB in the backend to store that information. So we pretty much leverage the same database to store routing information.
That was my next question.
Yeah, and whenever the rule engine, whenever there's any modifications to the priority, all the computation of the rule engine is loaded back to memory. So we are not, if the query is submitted, there's no read actually happening with the database. This is all stored in memory. But again, as long as the priorities remain the same. But during runtime, if there is change to the priorities, there would be a read operation to the database.
Okay, and how do you scale that? The when you're talking about the making it highly available, the gateway itself, is that all just done through Kubernetes? Like you just basically and you make sure that they are aware of each other in some sort of way, or is there a configuration that you would have to kind of plug in to basically make to scale the what am I trying to say? To scale out the different gateway pods.
Yeah, so the gateway in itself is a proxy, so it's stateless, and if stateless to the extent of just routing queries or forwarding requests from the client to the Trino coordinators. But in a case of in our case, in order to ensure that it is highly available, we can run close to 4 or 5 pods of the gateway simultaneously. So since they all store the routing related information in a DB, which is the only stateful information it actually needs.
Fantastic. And that's all pushed out to MySQL then.
Yes.
Okay. Great. So yeah, so these things you can just essentially unendingly scale, and that's all done in Kubernetes, and that's nothing in terms of the service doesn't have to be aware of any other type of proxies or anything like that. It's essentially just load balanced over those as they grow. Awesome. Very cool. And one last question. I was not a little confused about is the routing policy, is that open sourced or not? I thought I heard Yen said it was, and Preeti, I thought I heard you say it wasn't. Is it actually in the?
It's in the pipeline, so it's in an internal review phase, but it's not yet done. There is an addition. There's a simultaneous thread for the same feature by Lyft, and then there is ours.
So we got it.
Figure what goes in.
Fantastic. Okay, that makes. I mean, the beauty of open source, right? You're all trying to get in your version of the solution. So I love it. Well, thank you so much for joining us today. Thank you for the contributions that you all have made to the gateway. This is a huge step forward in terms of making Trino a much more resilient and a much more adopted project. And we have all of you to thank for it. So thanks for everything you do in the community.
Thank you, Brian. Thank you.
Thank you.
And if anybody wants to get a hold of you, is there anywhere we can kind of tell them to find you? Or any of you on basically LinkedIn, or is it or do you have Twitter? Or is there a good location they can go to find articles on electronic arts, big data stuff, anything like that?
All of us are on the Trino Slack channels. We would find us. You should. You would be easily able to look us up. And besides that, Yen, you want to add anything on LinkedIn?
Yeah, that's good.
Great. People, a few words, right? So great. Well, thanks again for all your contributions. Thanks for this presentation. This was wonderful. And we will have this up and available to watch afterwards. And so hopefully, maybe at some point, I'll work with one of you to set up a blog on how to set a lot of these cool features and functionalities up. So thanks for everybody who joined, and we will see you all in the next month when we do, actually in the next year even, when we cover, what is it? Oh, we're talking Trino at scale at Pinterest. So look forward to that, and we'll see you all then.
Thank you.